You want to know what your average paddling rate was for a canoe trip to a campsite. On the way there, it took you 9 hours against a river current of 2 kilometers per hour. On the way back, the same distance took you 5 hours with the same distance of, with the same 2 kilometer per hour current. Let R equal your average paddling rate. Express the rates against the current and with the current in terms of R to complete the table below. Using the information summarized in the above table, set up an equation to solve for your average paddling rate R. No problem. But first, what we want to address here is that when solving for distance, rate, and time, we need to remember that distance does equal the rate times the time. Okay, that's going to be important for us as we start figuring these out. So let's start first with the against the current. Okay, so here's something else that we know about these two. Whether you're going against the current or with the current, the distance is the same. They didn't say that the distance was ever different on this. It's the same trip, just one is with the river current, the other is against the river current. So when we want the rate for, let's say it's against the current, what we know about the current also is that it's running at 2 kilometers per hour, whether you're going with it or against it, okay? Now, with it or against, it's going to change the rate for us, and here's how. If you're going against the current, you have the rate that you're paddling out. So I'm using R. That's the value they told us to use. Again, this is against the current, so it's slowing you down. To show that it's slowing you down by 2 kilometers per hour, we're going to put subtraction between the R and the 2. It's your rate of paddling, but then take away 2 kilometers from the current. So if we were going with the current, you'd have your rate of paddling, but now that 2 needs to be added to your paddling rate because it's going to make you faster. These rates that we're talking about here, this is all speed, right? So the current can take away from your speed, that's why it's subtraction. Or if you go with the current, it will add to your speed. Now, something else we notice here is that if you're going against the current, that trip took you 9 hours. The reason why we need that is that's the time. So the time going against the current was 9 hours. Going with the current was 5 hours, so that's time as well, but that's with the current, and yeah, we did expect that to take less time. So this is how you're going to fill in those boxes. But now we need to fill in some kind of equation, right? Now the basis for our equation is you have the distance, which is the same whether you're going against the current or with the current. All right? So we know the distance. Now, instead of writing it as D, we're going to substitute it as rate times the time. But we know both of those values. Let's start with the rate. Okay, so instead of the rate, I have that expression for the rate, which is my rate of paddling, or yours, and it's against the current, so that's -2. And then we also know that the time it took was 9 hours. So I've got to multiply that by 9. And this should equal then the distance with the current, which again is it should just be rate times time. Well, we know both those values, kind of. The rate is an expression, and that's okay. Right, we know the rate is our rate of paddling, but then we have to add 2 kilometers per hour for the current. And then we know that the time that it took for the trip, so the T I'm replacing with 5. Okay, so this is the equation. I think this is the equation that they want. Now that I have it, I'm able to solve. I'll distribute the 9 into the parentheses. That'd be 9R minus 18. And then this would equal, distributing the 5 here, that'd be 5R plus 10. Okay, so I can use the principle of equality here to start solving this. So remember, whatever I do to one side, I got to the other side. I'm going to keep my R's on the left and then the numbers on the right. So the negative 18, I'll have to zero out by adding 18. But if I do it to one side, I got to do the other side. And then the 5r as well. I'm going to have to zero that out because it's on the number side of things. So I'll subtract 5r from both sides. So what happens here? The 9r minus the 5r's is 4r's. The 18's zero out. This would equal 5r zeros out. 10 plus 18 is 28. And you can see this is going to solve really well because I can divide both sides by 4, and it gives me my paddling rate at 7. Now, this is a word problem, so don't forget to label your answer. It said that the rates were in kilometers per hour, so I'm gonna label this in kilometers per hour. And that should work right there, right? And we can check up here back in the original equation. 7 minus 2 times 9 is 45. 7 plus 2 times 5 is also 45. So that checks off the distances. Of course, that means the distance was 45 kilometers, but I suppose that was kind of a different problem, but we were just checking the equation to make sure it was true.